In the readings for this module, you will find a link to download this week's data. I prepared a notebook for you, and I prepared data for you. So go ahead and go to the readings for this week, and click on the first link to download this week's data. Once you do, uncompress it, and move to the folder. And then simultaneously open up JupyterLab. So with JupyterLab opened up, what you're going to do is you're going to drag week3.ipynotebook into JupyterLab. And with that, it will open up the notebook. A number of you were asking last week, what is a notebook? And a notebook is a very simple thing. A notebook is a document. You can actually export it as like HTML and look at it in the web browser, but it's like a web page that lets you combine Python code and text, Python code and text, Python code and text. And the code you write them in these little cells, and you can press run to run them. So a notebook really essentially allows you to do something we call literate programming, which is it's a mixture of programming together with literacy, or lots of words that explain what we're doing. And because working with language models is really quite difficult, and I don't have that much time every week to really show you in depth how to do everything, I've decided to give you code ahead of time to play around with in the form of a notebook. Notebooks are also nice because they have a bundled together Python environment. You can run the same notebook also on the internet with Google Colaboratory, which a number of students have helpfully been pointing out. And most of all, it's private, so the code runs on your own computer if you choose to run it in JupyterLab. But before I go on and show you week three's content, I'm going to show you an additional data point that I've added for this week. And that is, under data, I've added a folder containing all the opinions that the Supreme Court released in 2014. So these take the form of these PDFs with long stretches of text written by a number of justices who are either for or dissenting against some decision that the overall Supreme Court is taking. So it's a bunch of PDFs, and we're going to be inserting all of them into our vector database. And if you wanted to insert more information into the vector database, like a whole bunch of PDFs, you can insert them into this folder. But without further ado, I'm going to now go through the code from last week, run the requisite cells, showing you along the way, and then we'll get into using a language model proper. So, moving onwards, because I've already run this step from last week, I don't have to run this one again. We then load LangChain's PyPDF loader. So we're going to run this, and it's loaded up PyPDF loader and PyPDF directory loader. And this is a new bit of code that I've added this week to load up a whole bunch of PDFs all at once. With that, I'm now going to load up one PDF. I hit go every single time, and it moves it. The active cell, which is highlighted in blue, moves down every single time I press go. So I've loaded up one PDF now. I'm going to press go again. It now has loaded up every single other PDF. And now I will load and split those. But it'll take a little bit of time because there are a whole bunch of PDFs in that folder. But it will do it at some point. And then once we've done that, we'll load our CSV, which, if you recall, is a series of award winners in Hamilton, Ontario for different funding projects, I think. So we've loaded up all the PDFs. We load up our document loader for CSVs. We run it on our CSV, and this, you might notice, this path, this file path, starts from this folder. So if I wanted to add the CSV from scratch, and it wasn't already here, I just type UR, I hit tab, and a little pop-up will appear telling me that this might be the file that I want. And if so, I press return, and there it is. So I continue pressing go. And because I've already installed sentence transformers, our embedding model from last week, I don't have to do that again. But I do have to import it. And to import code is to add it to our active Python environment. So now certain commands, like this command, are now available to us. So make sure you do every single cell in order. I've already demonstrated how to embed text. And then we set up Chroma. We first embed our single PDF, and then I add our CSV. And then I add all of our PDFs. And this might take a while because for every single folder and every single PDF inside those folders, it has to chunk them up into little sections and then run them through our embedding model. So let's just wait a moment for that. And we're done. So we've loaded up a whole bunch of PDFs. And you can add more PDFs in there if you'd like to. So we have two demonstrations of querying the database, and that's what it looks like when we query the database. So here, we're typing in what exceptions does Rule 606b1 contain? And we'll get back a series of documents which hopefully rather, contain the answer to our question. But regardless, let's now move on to week number 3. So we've prepared our vector database with a whole bunch of documents, and we're now ready to try making an agent. We'll start by downloading a library to let us run a local language model. And if you're on Windows, a non-Apple Silicon Mac, so if you have a MacBook that's older than 2020, or you're running Linux, use this command. But if you're running on Apple Silicon, use this command. And because I'm on a MacBook Pro from last year, I'm going to press go on this cell, not this one. I'm going to skip to this one. And what it'll do is download some requisite programs to run a language model locally. So it's going to build it for me, and I'll see a whole bunch of things telling me that it's doing this. And it's finished. Let's now load the software. So I'm going to press go on this section. So here we're loading Llama CPP, which is the name of our inference server, and we're loading 2 callback managers so that we can stream out tokens one by one. Next, I'm going to press go on this cell. Make sure you do this. It'll download this 4 GB file and put it inside your folder. This is Mistral. It is a single 4 GB gguf file. And once you've done that, run this code block to load it. I've now loaded Mistral. And to call it, I can type in something like, where is Hamilton, Ontario? And the model responds. So the answer, Hamilton is a city located in the Canadian province of Ontario. It is situated on the western end of Lake Ontario at the mouth of the Niagara River. And I can type in things like, how are you? And of course, it doesn't have any feelings because it's a computer. But regardless, here's running, where is Tokyo? We now have a language model that we can ask questions for locally. Now we move on to the next step. So we have the language model and we have the data. Now we have to create a tool so our language model can use the tool to answer questions. Because if I asked it a question like, for example, let's go back up to this question. If I ask it a question like, what exceptions does this particular rule contain? Chances are the language model won't know. Oh, well, it seems like maybe it does know, but maybe that's not right. Anyway, we don't know. I have no clue if this is right or not. And in order for me to know that it is right, I have to make sure that the model is getting it from a document. And in order to do that, we have to set up some code blocks to allow the model to first initialize an agent, to create a tool, to have a particular type of agent, because there are many agents. Some agents, you can give them memory so they can remember the conversation. Other ones, they don't have any memory for the conversation. And in particular, we're going to have some code for creating a retriever tool. We're now going to instantiate that retriever tool, and then we're going to define a tool called search knowledge. This brings up a very interesting point. Language models have to decide to use a tool. They are reasoning engines. They have to decide to use a tool. And in many cases, if it doesn't think that it has the right tool on hand, it simply will not use a tool. And that's a little bit problematic, especially when we have a single tool that combines multiple domains of knowledge. In other words, if I had a tool called search Hamilton data and search Supreme Court data, the language model might pick between the two. But here, I'm only creating a single database. And because of that, I have to make a very vague tool called search knowledge. And the language model will see that as a tool in its toolbox called search knowledge. And I've defined this tool as useful for when you need to answer a question. If the user asks a question concerning the Supreme Court or Hamilton, Ontario, find the answer to the question with this tool. Only use this tool once. I press go on this block, and I've now defined the tool. And I can see that by typing in tools, and I can see that it has a single tool called search knowledge. And with that, I'm now going to define our agent. An agent, if you recall, is composed of tools, a language model. Here it's composed of a language model type, which is zero-shot React description, and we want a verbosity of 0, or no verbose response, because sometimes if you're debugging a language model, you want to see what it does precisely. Here, we're going to be ignoring that. And with that, I'm going to ask it a single question. Have any businesses in Hamilton recently won a grant for art? And I'm going to press go. So here, we can see that the language model decided to search its knowledge and looked up grants for art in Hamilton. So this query is going into the vector database just as we did up here. So just as we searched up what exceptions does Rule 606b1 contain, the language model looked up what businesses in Hamilton recently won a grant for art. The language model then determines that it found 4 businesses in Hamilton that have recently won a grant for art, and it says that. It does not give me very much detail because I technically did not ask for a detail. If so, what are they? I'll now go again. Here. The Art Gallery of Hamilton Renewal and the Gasworks Cultural Center have recently won grants for art in Hamilton. And that's the answer. So in answering my question, it really actually went to my CSV and I looked up which of these won one for art. So here's one, the Gasworks Cultural Center. It's a heritage structure, non-profit community art center. That sounds like it's correct. And a lot of these are not related to art, like a farmer's market, suites, a restaurant, etc. So it successfully looked up the CSV. It found the most relevant rows, and then it read it, and then it answered my question specifically. I could also ask it a question about the Supreme Court. Of something like, has the Supreme Court voted on X subject? But I won't do that here. And with that, I encourage you to download this notebook, download the data, and run through it yourself. Try it out. Try feeding it your own data, and let me know in the forums what you think of retrieval augmented generation. As always, I'll be available on Wednesday for answering questions. If you want to complete the course, you should remember to answer the discussion forum questions, complete the quiz, complete the readings, and watch the videos. So thank you very much, everybody. I hope you have a good 3rd module of the course, and I look forward to meeting you all again next week. Thank you very much. Have a good day. Bye-bye.